Hey there, geometry. So we are back with some videos. I'm going to try to make this a little bit simpler on you guys. I know the last little while's been crazy. Hopefully yesterday you felt like you did okay on your assessment. If you feel like you did okay, those grades are going to be up on RunUp as soon as I'm able to get them in there. And I'm not even going to wait for everybody. I'm just going to put your grade in there so you'll be able to see it. And if you feel like you did okay on that, then you did okay in Chapter 7. We're just going to kind of call it quits there and move on. Whether we leave that as our full assessment or not is still to be decided, but we're going to be able to say we understood the key components and we're going to keep going. So we're going to look at some circles here in Chapter 8. A lot of vocabulary, a lot of really intense problems in the book. So most of your problems are going to kind of come from videos this week, so that I can simplify some of the things that I think our book overcomplicates. So let's press through, do our best. I know that I don't have the most thrilling videos, and I'm no YouTube sensation, but at least I'm better than reading the book, hopefully. I don't know. Hopefully you have like a watch this 2 times as fast kind of thing. All right. Let's pull out your interactive notebook and get started. All right. So Chapter 8.1, Circles and Chords. There's a lot of information in here. Stick with putting down what I have for your notes, and hopefully that'll cover most of what you need. I'm going to also put a link to the YouTube video. I'm sorry, it's not a YouTube video. It's the video that goes with the BJU books. I've tried to watch a bunch of them, and they are interesting. So if they are helpful to you, please use them. But I'm going to try to make my own and hope that helps you a little bit as well. Okay, so here's our circle. The center we'll call C of our circle. And then we could have any given radius. And a radius comes from the circle center to its end point. And we will call it R for radius. Okay, no new news there. All right. The part that's a little bit different is talking about what is a chord and what is a segment. And we talked about sectors being like a piece of your pizza or a pie from a circle. It's possible that we would have some line. Let me make sure I find an okay color here to use. Some line that would cut through my circle. And that line is then going to intersect my circle at a few different points here. And then we are left with, let's call this A and call this B. We have some line AB, but we also then have a line segment AB, that section here between A and up to B. And this is called a chord. So from A, B, and we're going to write it as chord A, B, and it has a little line, because technically it's just a line segment, right? All right, so here is my chord. Any chord, or any line, or any segment that is, have endpoints that lie on the circle is called a chord, okay? So if they're endpoints, and I'm talking about those points of this, not the whole line that's blue, that yellow part. If the endpoints are both on the circle, then it's a chord, okay? So we can draw a few other chords. Try to make these yellow also. I mean, it could be anywhere. It could be a short chord. You could have a really long chord as well. All of those are different chords of the circle because their endpoints lie on the circle itself. Now, one other piece of vocabulary that we're going to need here is that this line itself does have a name. It's called a secant. All right, and a secant is just a line that intersects a circle in 2 points. So it intersects it here and it intersects it here, thus creating this chord here. But the line itself that's blue is called a secant, and it's a line that happens to intersect a circle in exactly 2 points, no more and no less. So if a line came, and we'll talk about this later, and I kind of missed the boat here, if it only intersects it at 1 point, that's called a tangent, and that's not what we're talking about. We're talking about a secant. It intersects at 2 points. The yellow portion here is called a chord. Okay, so that's the difference between those two. Now, it's possible that you would have a line that would go and intersect my circle at 2 points here, right? This red line, but because it goes through the center, it's a unique type of line here and a line segment. It's called the diameter, right? It's consisted of 2 radius. So this diameter is a unique type of chord, all right? And it's not really going to be called a chord because we're just going to call it a circle's diameter. It's going to be more referred to in those ways, but technically it is one. Okay, so then let's see. I'm trying to find another color here that we can use. So when you have some sort of a chord, you now have created this arcway. So this arc, you could have this from an angle also, is the portion of the circle's circumference that's chopped off there, or that's endpoints are the points of a chord or of a diameter or of an angle as well. Okay, so don't forget that's called the arc. We've got a chord which has 2 endpoints. On the circle itself, we have a secant, which is a line that intersects a circle twice. We have a diameter, and we have a radius. All right, here's some more information here. Here's another circle. Go ahead and continue to put these in your notes. Those were all the pieces of our circle that we need to know. But we've got to talk about some postulates and theorems, and we're mostly just going to kind of talk through what happens. So if I have a line that intersects the interior of a circle, then it contains a chord of the circle. So anytime I have a line and the line intersects the interior, it cuts through inside, then I therefore must also have some sort of a chord. Okay? If the line goes through the middle of a circle anywhere, even if it's a little bit or way in the middle, because of the nature of a circle, it's going to intersect at 2 points. So that's kind of obvious, but it's something we got to talk about. It's the chord postulate. Okay? The next one is, it's called a theorem, and it states that if the radius is perpendicular, so let's say that we have this red radius, and it creates a 90-degree angle with some chord. Okay, every radius is going to have some sort of a chord that it's going to create a 90-degree angle with, wherever you might want to put that chord. Well, what we know is that if, get a different color here, if this radius is perpendicular to the chord of a circle, then it bisects that chord. Let's call this chord AB. Well, this is a bisector. So now I know that from A to the radius is the same distance as B to the radius. It gets chopped in half. So we can also say the other way around. If some line segment is bisected by a radius, that radius and that chord are going to be perpendicular to each other. Okay, and I should have called it a chord originally. It could be on a line segment. It is a line segment, but more specifically a chord because it's in a circle. Okay, so if the radius and the chord are perpendicular, it got bisected. If it's bisected, then they are perpendicular. It kind of goes back and forth and they work together. There is one exception to this, and that is if you were to have a diameter, I guess it should be a point here, okay? Technically, this radius here is bisecting it, right? Because it's chopped in half just by the fact that it goes through the center of the circle, but it doesn't mean that they're perpendicular, because look, I could draw another one over here, right? I could draw any of these diameters, and this same red radius is going to cut it in half. And so this is only true if your chord is not a diameter. And remember, every diameter is technically a chord, but we're going to refer to it. It's so specific and such a unique property that it can't be, your chord cannot be a diameter as well. Okay, so every chord that is bisected, this is still so true with a radius there. Only exception is if it's a diameter, and there's lots of other things that will happen with a diameter. And lastly, if there is any chord, take this yellow one, and you have some sort of a line that bisects it, okay, if it chops it in half, this line here is going to have to go through the center of the circle. Think about it. This is the radius hidden inside of here, and that radius has to go through the center. That's kind of interesting, right? Doesn't matter where you put that. You could draw another one out here, have a tiny little chord, and if we were to find some line, if this bisects it here, it also has to go through the center, thus containing the radius in it. So this part here is always true. Really neat. All right, let's do an example. So let's say we have a circle O. Remember, circles are named like this, circle O. That's supposed to be an O. I don't know why we're calling it O. Does it look so much like a circle? I'm going to rename it. Your book doesn't do that, but we're going to call this circle M. So let's call this circle M just so we see the notation there a little bit better. Find the diameter of circle M if MD is equal to 3 and AB is equal to 8. Well, let's get a little bit more information on here. So I've got a line here. This point is C. And I have a chord that is also here. Okay, this chord is called AB. It is given that these two, MC and AB, are perpendicular to each other, and they intersect at some given point here. We're just going to call D for the sake of naming the intersection. Okay, so we need to find the diameter of this circle. Well, the diameter we know goes all the way across. But we also know that the diameter is equal to twice of the radius. So if we can find the radius, we can find the diameter. So let's get that off of there. I'm going to keep the diameter is equal to 2 times the radius. Okay. So let's take a look here. We're going to need to apply the Pythagorean Theorem a little bit because I don't know that we have enough information. So I'm just going to say that we really, anytime you have a chord, we have a couple different triangle things happening here. Okay? All right. So we know, here's some more information. We have circle OM. We also know, circle M. We also know that MD, segment MD is equal to 3 inches. And we know that AB is equal to 8 inches. Okay, well, let's just take that first piece of information. If I know this whole thing is 8, well, go back a little bit. We know that this is a right angle, and that means that my chord gets bisected. So if this is a right angle, then this AB has to be cut into half, okay? So I know that this got chopped into half. So if I take half of 8, I know that this little section here, AD, I'm going to get a different color, sorry. AD is 4 from here to here. So is DB is also 4 inches. Okay? All right. Now, it still doesn't really help me. I do know that this section here is 3. So I know this part here is 3. But I need to go all the way across. I don't really know all the way across yet because I'm missing this piece of information right here, and I need something that's all the way across. But you know, this here, if I were to pull this little triangle out, I don't know if you could kind of zoom in on this section right there. If I pull this triangle out, I know that it's a right triangle. And I know that this hypotenuse here is the same as this dotted line right here. And this dotted line here happens to be a radius, and once I get the radius, I can then find the diameter. It's also given that this is 4 and this is 3. Think back to your Pythagorean triples. If you want to apply the whole Pythagorean theorem, you can. A squared plus b squared equals c squared. And we would have 3 squared plus 4 squared equals c squared. You get 9 plus 16 equals c squared. We would have to take the square root of both sides. I'm going to kind of come over here. I'm losing space. C is going to be equal to the square root of 25, or plus and minus 5, except I can't ever have a negative distance, so C is equal to 5. Or you can just remember, hey, 3, 4, 5, that is a Pythagorean triple. Those will really help you save this entire section of work right here. You could just completely eliminate all of that by knowing your Pythagorean triple. All right, so now I know this distance here to be 5. I guess I should use purple again. So if my radius is 5, and I double that, I should get my diameter. So my diameter is equal to 10 inches. There you go. Quite a lot of work just to find the diameter of that one, I know. Okay, this is where we're gonna stop for notes for today, and I want you to try, flip over to page 347 in your book. I want you to try numbers 1 through, let's just go, let's go to 7, 1 through 7, okay? Try numbers 1 through 7 on page 347. Pause this video, try them on your own, and then come back and we're going to check them together. So hit pause. Okay, so here's the picture you have for 1 through 3. Hope you feel like you did okay on it. We'll go over it together so you have a little more confidence. First thing we need to do is just name the circle. Well, we talked about it earlier, how we just draw a circle with a dot in the middle, and then we name it by its center. And the center in this case is P. So circle P. Its center is P, so that's the next question, and it has a diameter. Well, one diameter has to go through the center and to each side. So the diameter is going to be AF, and it's a line segment. Okay, that's the answer for number 1. Now, we need to know 2 different chords, and we know that a chord has to intersect a circle at 2 given points going through its interior, and we know that a diameter can be a chord, and so we'll just already write that one down. AF is definitely one. And the other one that goes through 2 points is NF. Now, NP has 2 endpoints, but this P is the center. It is not on the outside of the circle. And number 3, name 3 radii. All right, well, radius has to start in the center, so we can already rule this one out, and we then have 3 choices left. We've got this one here, AP is a radius. We have this one here. Oh, I need the lines over these guys here. Okay, AP, we have PN, and we have this last one here as PF. Okay. Number 4, 5, 6, 7, and 7. I guess that's where we stopped. All right, so here's the picture that we have. It's circle O, noted by or named by its center. And I've drawn the picture here for you. Y doesn't look really clear to me where it is, so I'm just going to write it underneath. DC is that length there. Okay, so number 4 asks us to say how long is this segment AD? Well, I don't have any number for it, but what I do know is that this line here creates a right angle with my chord AC, and if you remember, if you have a chord, it has to bisect. It is bisected if you have a chord that creates a 90-degree angle with some line through it, and that line will then have to go through the center point. Okay, so we know then that this section here and this section here are equal to each other. Well, if I know that DC is Y, well then AD is also Y. That's your answer. What about AC, the whole distance all the way across? Well, if we have Y and another Y, it's just 2 of those, Y plus Y, or 2Y, and I'm going to get rid of this part on my circle here. 2Y would be the whole length, right? If you have some length, and this part is Y, and this part is Y, the whole thing is 2Y. Number 6, I want to know OA, and that's that dotted green line there. This is going to get a little bit more complicated because I don't really have numbers like I did earlier. But if you look right here, I have a beautiful triangle with a right angle. And anytime you have a right angle, we can use the Pythagorean Theorem. Well, the Pythagorean Theorem says a squared plus b squared equals c squared, where c is your hypotenuse. So if we rewrite this using algebra, and we have this in our interactive notebook, I did all of the math in a sense for you, you can find c to be the square root of a squared plus b squared. And we're looking for c, and we know that this a and this b are my legs, and they happen to be x and y, and I don't know any more than that, but I can put it in as x squared plus y squared, and that will give me my radius, or the length of AO. Is that what they're asking for? AO or OA. Okay. All right, and last but not least, number 7. Come down here and put this over here. They want to know OE. Well, OE is a radius, isn't it? From a center point to an end point. Well, wasn't AO also a radius from the center point to an end point? So those have to be the same distance. It doesn't really matter what it is. I still don't know the number, but that's going to give me the same answer. So the answer to number 7 is that C equals, or you can just say that OB, or OE, is equal to the square root of x squared plus y squared. And that's it. Okay, I hope you did all right on these. Followed a little bit. We will check in tomorrow with a couple more.